Okay, so welcome back, and now we're going to do another one. And again, it's just a very simple, straightforward process for doing these Maclaurin polynomials. The only difference is we're doing a equal to 0, okay? And so it's a Taylor series, a specific type or particular Taylor series where a is equal to 0. So that's what we're going to use, okay? So the first thing we're going to do is, again, fill out this table that I have, right? So we're going to do the derivatives. And so the first derivative of sine, right? So the first derivative, the derivative of sine is cosine. And then the derivative of cosine is negative sine. And then the derivative of negative sine is negative cosine. Okay? And so now we're just going to evaluate these at 0. So sine of 0 is 0. Cosine of 0 is 1. And then negative sine of 0 is 0. And negative cosine of 0 is negative 1. Okay? Now we're pretty much ready. Because now this, again, is just f of a. This is going to be f of a plus f prime of a times x minus a, right? And again, this is f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial times x minus a quantity squared. And then this one is f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a divided by 3 factorial times x minus a cubed, right? So this is just the general Taylor series. So only difference is a is 0, right? So all of this just becomes 0, right? So this becomes 0. So all of these become 0, right? So I'm just going to replace these with zeros. 0, 0, 0, 0, 0, 0. And of course, all of these x's, right? These x minus a's just become x's, right? So this is x, x, x. And this is going to become x squared. Oops. X squared, x squared. And this just becomes x cubed, right? And then all we're doing is filling these in. Okay? So let's do that. Well, f of 0 is just 0. So this just becomes 0. So the first Maclaurin polynomial is just a constant function at 0. The second P1, P sub 1 of x, is going to be what? Well, this is 0, right? So I'm not going to include that. But then this is just 1. So it's just going to be x. So the second one is just going to be x. And in fact, for these, I can just get rid of these because it's just going to be 0. And these are just going to start with x, right? And then what's the next one? P2 is going to have x, but it's going to include this one, which is, this one is 0, so this becomes 0. So it's just x, right? And so let's just make sure that that's right. Yeah, P, so that's 0. Yeah, so that's going to be 0. And 0 divided by anything is 0. And so this is just going to end up being x again. And then what P3? Well, P3 is going to be x this just turns about to be 0, but what about this one? This is going to be negative 1. So it's going to be negative 1/6. So this is going to be x minus 1/6 x to the third. All right. Well, what would the nth term look like? Okay, now, since the fourth derivative is just sine x, right? So let's look at the fourth derivative. Well, we know that the fourth derivative just brings us right back to this. So this is a repeated pattern, right? So, we know that every other one is 0. So if you look at this, these are 0 and these alternate between 1 and negative 1. So when we're dealing with these cyclic patterns, we have to be a little careful here, okay? In order to find what the nth polynomial is going to look like. Okay, so we know, based on this, is that for each even, right? For each even polynomial, we get this. So for every each even derivative, let's say, for each even derivative, so we'll do 2m, where m is an integer, right? Positive integer, or non-negative integer, I should say. So for this of 0 is going to equal 0. And for each derivative that's odd, which we'll do 2m plus 1 of 0 is going to equal negative 1 negative 1 to the let me think. Is it 2m? Will 2m plus 1 work? Yeah. Yeah, so we'll do m, and this is going to be for all m greater than or equal to 0. Okay. So we know, again, so this is true. Let's box this off. So we know this is true for this function. Okay. So, what do we do with that? Well, let's figure that out. Okay, now, what does this give us? Well, like I said, we've got the first 3. Okay, so let's continue on. And now what I'm going to do is I'm going to write this out with all of the terms. Okay, so I'm going to keep the zeros in there as placeholders. So the first one is going to be 0. And then the next one is going to be 0 plus x. And the next one is going to be 0 plus x plus 0. And the next one is going to be 0 plus x plus 0 minus 1/6 x to the third. That's what we had before, right?
Call from truck support.
Okay, so now, get out of there, Haley.
Call from truck support.
So,
Call from truck support.
let's see here. Where is...
Call.
Okay, so now we've got this pattern, right? So we know that this is going to keep repeating itself. Okay? So, what's going to happen here? Well, if this is going to equal 0, this is going to equal x, this is going to equal x, right? P2 is going to equal x, and then P3 is going to equal, like I said, it's going to be x minus 1/6, or, you know what? Let's keep it as factorials. So this will be 3 factorial. So this will be 3 factorial x to the third, so we can see the pattern better. Okay? So now that it's going to repeat itself, what happens with P4? Well, P4 is just going to be the same thing plus 0, right? So P to the 4 is just going to add a 0. So this is going to end up being x minus 1/3 factorial x to the third again. And then if I do P sub 5 of x, well, now what's going to happen is I'm going to add another x to this one. So this is going to end up being x minus 1/3 factorial x to the third plus x, which means now I'm going to have 2x, right? So this is going to end up being 2x minus 1/3 factorial x to the third. Okay? And then, for n greater than or equal to 0, we see, okay, so let me write it over here. So for m greater than or equal to 0, what we have is this relationship. P sub 2m plus 1 of x is equal to P sub 2m plus 2 of x, which is equal to this. You know what, I'm going to erase this because I don't have any more room. Actually, you know what, I'm going to erase this up here. So I'm going to keep this. Okay, actually I'm going to erase this here too. It should be in your notes. Okay, and so what do we have? We have 4 m greater than or equal to 0, P of 2m plus 1 of x is equal to P sub 2m plus 2. Right? Of x, which is then equal to what? Well, what do we notice here? We've got this one and this one. Right? And then we've got these two. right? And if we keep going in like fashion, what do we end up getting? We end up getting this. X minus 1 over 3 factorial x to the third plus 1 over 5 factorial x to the fifth plus all the way to plus, so it alternates by signs, and we get negative 1 to the m right, for the alternating signs, and we get x to the m, hold on a second, is it m? 0, hit. No, m plus 1. M plus 1 over m plus 1 factorial. I think that'll work. Let me verify that. Okay, now so now, this is the nth term. So now how do we write this as a summation? Well, then what we're going to do is we're going to write p sub n of x is equal to, again, I'm going to use a different index variable, k. So k is going to equal 0 to n. And I know this is going to be the nth term, but I got to make sure that I get all of the terms, okay? And so in this case here, basically I'm just going to take this and put it here and use k. So this is going to be negative 1 to the kth power times x to the, oh wait a minute, hold on a second. No, this won't work. This should be 2. 2m. Sorry about that. This should be 2m plus 1 here. So, yeah, because it won't work if it's just m. Because you get extra terms in here that you shouldn't get. So if you do 2n plus 1, then that'll work. Because if you have 0 here, you'll get 1. And if you have 1, you'll get 3. Yeah, that'll work. Okay, so now this will be 2k plus 1 divided by 2k plus 1 quantity factorial. And then this is the result. So let me block this off. Like so. Okay. So now, that's it. So this is the representation for the nth Maclaurin polynomial for the function of sine x. We'll do another one.